Hi everyone, in this video I am going to explain about classification of codes. Classification of codes or classification of binary codes. You can also call it as binary codes. Binary codes. So classification of binary codes. When a number is given to you like 10, how you are going to represent this 10 in a ones and zeros format in binary format? You are going to represent that number as 1010. This is the standard format which we generally follow. So 1010 is nothing but here each number is going to be multiplied, each digit is multiplied by its weight. So it is the weight is here 0, so 2 power 0, and here it is 2 power 1, 2 power 2 and 2 power 3. So according to the weights of the bit positions we are going to take this values. Always it starts from, for the as it is a binary number, always it starts from 2 power 0. So 2 power 0, 2 power 1, 2 power 2 and 2 power 3. The corresponding equivalent number of this 2 power 0 is 1. 2 power 1 means 2. 2 power 2 means 4 and 2 power 3 means 8. So we call such number which we are going to write generally is known as 8421 binary code. 8421 code. Okay, it is a format or a coding mechanism to represent a particular decimal number. Okay, with the same, suppose see here where we in which positions we are having ones 8 position and 2 position. Okay, that means 8 plus 2, remaining 2 are zeros. Okay, as we are writing it as 1 into 0 plus 2 into 1 plus 4 into 0 plus 8 into 1. So 8 plus 2 is nothing but 10. For the same, if you want to represent 15, how you are going to take 15? 15 is nothing but all ones. All ones. So 8 plus 4 plus 2 plus 1. In 8421 code, you has all are ones. So it is 8421 which gives 8 plus 4, 8 plus 2, 10, 15. So it is 15. Okay. Similarly, if you are taking 1000 means only 8 is activated, remaining are gone. So it is equivalent to 8. Okay, so the given code is converting, given number is converted into its corresponding binary information by taking 8421 code. But remember, 8421 is not only the code available for the binary information. We are having several number systems, several uh, coding mechanisms, several coding techniques. Those coding techniques are classified into different types like numeric and alphanumeric codes, weighted and non-weighted codes, positively weighted and negatively weighted codes, error detecting and correcting codes, sequential codes, self-complementing codes, cyclic codes, reflective codes, straight binary codes. All these are different types of codings. Okay, suppose if what I said, if I write all these, first one is numeric and alphanumeric codes. Alphanumeric codes. And second one is weighted and non-weighted codes. Weighted and non-weighted codes. Third one, positively weighted and negatively weighted codes. Negatively weighted codes. And fourth one, error detecting and correcting codes. Error detecting and correcting codes. Fifth one, sequential codes. Sequential codes and self-complementing codes. Self-complementing codes. And next one, cyclic codes. Cyclic codes, reflective codes, reflective codes, and last one straight binary code, straight binary code. Okay, so numeric and alphanumeric, numeric and alphanumeric. Suppose we are having 8421 code, as I said earlier, 8421 plus you are having like A, B, C, D, E, F. Up to F we are having numbers. Up to F we are having alphanumeric alphabets. Okay, such type of codings are numeric and alphanumeric. So numeric codes are the codes which represent numeric information. Numeric information. And alphanumeric codes are nothing but which represent alphanumeric information like letters and alphabets for the decimal numbers. Okay. So here the numbers and alphabets. Numbers and alphabets you are having. And weighted and non-weighted codes are nothing but these weighted numbers obey position weighting principle. Position weighting principle. So according to 8421 code, if you are saying 1 is obtained by taking the weight of that particular position and 2 is obtained by taking weight of that particular number 8421. So these 4 digits we have obtained by taking the weights of their positions. And positively weighted codes and negatively weighted codes are nothing but all the weights assigned to the binary digits are positive. That means here in positively weighted codes, all the weights are positive and all the weights are negative in negative weighted codes. Okay, according to that, we are going to represent the binary information. I will give you a few examples also how to represent the 8421 code and what are the other codes we have. 8421 as well as 84 minus 2 minus 1 also we have. That is the negative weighted codes. Okay, for example, for positive weighted codes, we can take example as 8421. But for negative weighted codes, we can take it as 84 minus 2 minus 1, where the weights of the particular numbers 2 and 1 are negative. So according to that, we need to write the binary information of the given corresponding decimal number. And error detecting and correcting codes. Error detecting correcting codes are used to identify where the errors in the particular given number. When information, suppose these particular error detecting and correcting and one more is cyclic codes. Okay, all these coding techniques are used in the transfer of information from one place to another place. Suppose in a communication, when we are transmitting a bits of information from one place to another place, a long distance, then what we need to do? We need to add some parity bits. Okay, original information is going to be mixed with parity bits, and as well as that information is transmitted through a channel, and receiver will receive that information. We cannot expect the same 100% information will be received by the receiver, as well as some amount of noise will also be added to the original message, original information. Okay, that means this particular noise is added in terms of bits, because in digital communication we are transmitting the information in terms of bits. So those bits are corrupted, so 1 may be converted into 0, or 0 it may be converted into 1. So in order to identify where the error is, and in order to correct that particular error, we are using this error detecting and correcting codes. Okay, and sequential codes are nothing but in which each succeeding code word is one binary number greater than its preceding word. Okay, sequential code is nothing but previous number should be greater than the next number. These codes are examples here: 5211, 5211, 2421 code, and 642 minus 3. These particular codes are not sequential codes, except these remaining codes are sequential. These codes are not sequential. These codes are not sequential, except these four, except these three. Remaining codes are sequential. What are the remaining codes? I will tell in the next slide. And self-complementing codes. Self-complementing code. What do you mean by self-complementing code? A code is said to be self-complementing if the code word of the 9's complement of n, that is n minus 9 minus n, can be obtained from the code word of n by interchanging all zeros to ones. Okay, self-complementing is nothing but 9 minus n can be obtained. Suppose a number is given to you like 4, listen carefully. A number is given to you like 4. When we are performing 9's complement is nothing but 9 minus the given number is equal to, here we have 9 minus 4 is equal to 5. If we perform ones to zeros and zeros to ones of this particular number, then that number will be again equal to the given number. Then we are calling that number as self-complementing code. Okay, so n is a number. Here we are taking, when we are performing 9 minus n can be obtained, 9 minus n can be obtained from the code word n by interchanging all zeros and ones. Okay. Next one is cyclic codes. Cyclic codes are those in which each successive code word differs from the preceding one. Each successive code word is differed from the preceding one. We cannot use the same number. They are also called unit distance code. They are also called unit distance codes. The example for this one is a gray code. Gray code. Example for this one is a gray code. Suppose 0 0 0 0. The next number should be 0 1. From here to here we should have only one unit distance. One unit distance is nothing but only one number should be changed. Again, that means 0 is converted into 1. 0 is 0 only. How many units of change is there? 1 unit. And again 1 should be followed here, and here 1 again converted into 1. So the next number is 1 1. 1 1 is nothing but only one unit of distance. See, 1 is same but 0 is converted into 1. Next number 1 and it is converted into again 0. This is unit distance code. Example, gray code. This particular data which I have given here is nothing but a gray code. And coming to reflective codes, reflective code is a binary code in which n least significant bits for a code word 2 power n through 2 power n minus 1, 2 power n plus 1 minus 1 are mirror images of those codes. Okay, reflective codes are nothing but, suppose I will tell you example here. So cyclic codes example is gray code. Example is gray code. So what I said, 0 0. Next one is unit distance, 0 1. So here we have one unit distance. One unit distance. More than this is not allowed. Again 1 0. From here to here unit distance. 1 1. Again here. Sorry. See here, 1 should be common, and again this will be converted to 1. So 1 1, again 1 unit distance. Again this number is again 1 0. This is again 1 unit distance. So this is the example of cyclic codes. This particular coding system is known as binary code. Next one is reflective codes. Reflective codes. So reflective codes are mirror imaging codes. We can also call this as mirror image codes. Mirror image codes. See, first you need to take 0 and 1. Listen carefully. 0 and 1. Again this will be converted into 1 0. We are taking a mirror and this is the mirror image of the given number. Append 0 0 1 1. Again take mirror image 1 0 1 1 0 1 0 0. Again take 0 0 0 0 1 1 1 1. Again take mirror image. Hope you understand. See, first you have started at 0 1, taken the mirror image, Next, appended first two zeros and the next two ones. Again, we have taken the mirror image, appended zeros for the first four and next four ones. Again, mirror image, and append zeros for the first four and ones for the next four. Then total 15 numbers will come. These are reflective codes. And straight binary codes. Last one is straight binary codes. Straight binary codes are used to represent numbers using natural binary from discussions of this reflection codes. So various arithmetic operations can be performed in this particular straight binary format. Straightly we are writing the binary whatever the information. It is also, we can also say that it is a 8421 code. Okay, these are the different types of classifications of codes. So most commonly we can say codes. It's a, if we are going to draw that in a tabular form or tree form, numeric, alphanumeric, again numeric examples are weighted, non-weighted, self-complementing, sequential, error detecting and correcting codes. I am writing in short, error correcting and detecting codes, reflective code. Next, cyclic code. In alphanumeric, we are having specifically only 3 ASCII code, and next EB, EBCDIC code and Hollerith code. And coming to cyclic code, I told you is example of gray code. It is example for gray code. Reflective code is also, I said, it is a gray code. Image, mirror image code. And error detecting and correcting, we are having two methods here, parity and another one is Hamming. Okay, when you are studying digital communications, you can come across all these points, all these terms. And sequential, sorry, sequential again 8421 code and XS3 code. XS3 code. So self-complementing codes are 2421, 5211, and you can also say XS3 code. XS3 code is nothing but basic 8421 we will take, and then plus 3 number is the XS3 code. So non-weighted XS3 code, gray code. Next, 5-bit BCD codes. 5-bit BCD code. And coming to weighted codes are again classified into broadly two types. One is binary, another one is BCD, binary coded decimal. BCD is nothing but binary coded decimal. The maximum number of BCD is 9. BCD is 9, binary coded decimal. And here in this BCD, binary coded decimal, we are having several different forms of codings: 8421 code, 2421 code, 3321 code, next 4221 code, 5211 code, 5311 code, 5421 code, 631 minus 1 code, 7421 code, 74 minus 2 minus 1, and 84 minus 2 minus 1. These are the different codings available in the BCD, binary coded. Okay, suppose consider 5 as 50101. This is 8421. Okay, we can take 8421 code, and this is 5. For the same, if you are going for 2421 code, 2421, see 2421 means 2, 2, 4 plus 1. You can take 2, 2, 1 or 4 plus 1. Okay, so you can take this one also, 1011. And 5211, wherever 5 we have, there 1 remaining are zeros. And in 5421 also you can take the same method. But see, in 8421 it is not equal to 5, it is like 8. Okay, that's why when you are taking the binary corresponding number, decimal number into binary, then you have to mention that it is in 8421 code. Okay, these are the different codes and its classifications. Thank you.